So let us now apply the idea in an actual problem. This is the figure given to us, and I know that LM is parallel to BC. That means this line is parallel to this line, and also that LN is parallel to DC. So LN is parallel to DC. And it is given to me that AM is to MB is 1 is to 3, and the question is what is AN is to ND. So this figure, these two lines are parallel and these two lines are parallel, and I have some information about this side. So how will I go about doing that? And the beginning point should have been obvious to me. These two lines are parallel. That means I'm thinking of triangle ACB. This is a parallel line to this side. That means this line will divide the side AC and AB in the same ratio. That means if the ratio of AM is to MB is 1 is to 3, the ratio of AL is to LC is also going to be 1 is to 3. And again, we're talking about ratios, not actual values. So this is part of the story that I've got, and now it should be very, very clear. This line is parallel to this line. That means now if I think of the triangle ACD, this line is parallel to one side. That means it will divide the two other sides in the same ratio. And I know AL is to LC is 1 is to 3. That means this is also going to be 1 is to 3. So my question was, if this information is given to me, what is the ratio of AN is to, ND? Your answer would be 1 is to 3. And even if the question was AN is to AD, it should not be too much of a problem because I have worked this out. Let me say this is 1x, this is 3x. My question is, what is the ratio of AN is to the whole thing? That means 1x plus 3x, 4x. That means AN is 1x for me and the total is 4x for me. So xx will get cancelled and I will get 1 by 4. So once I have the ratio of the parts, the ratio of a part to the whole, finding that out should not be too much of a problem for us anyway, especially if we have already mastered ratios. Even if not, it's a very, very simple idea. Just work it out for yourself and you will see. Though, once again, I can create a theorem around it. I can say, if there is a triangle and I draw a line parallel to one side, it will divide the lines in such a way that the ratio of A is to C, C being the whole thing, will be the same as the other side, A is to C. But this idea can be derived very, very quickly, because if you have the parts, if this is B, that means this will also be, if this is B, this is A is to B, this is also A is to B. And if C is the total, the ratio is going to be A upon A plus B. The ratio for this is going to be A upon A plus B. I'm assuming that C is equal to A plus B, so the whole thing. Don't get confused in the names might get confusing. Consider the idea. If this is 1 unit, this is 3 units. I know the ratio is 1 is to 3. I know the total is 4. So the ratio of the part to the whole is going to be 1 by 4. The ratio of this part to the whole is going to be 3 by 4. So jumping from this idea to this idea should not be too much of a problem. An almost immediate application can be a trapezium. So a trapezium is where one of the opposite pairs of sides is parallel to each other. So if I call this A, B, C and D, I know in this case AB is parallel to CD. AB is parallel to CD. So this is the starting point of the trapezium, that a trapezium, a pair of opposite sides is parallel to each other. If both the pairs were parallel to each other, you would go into the theory of parallelogram. But as of now, staying with the trapezium. And now I draw a parallel line, say E and F, to DC, and because it is parallel to DC, it will also be parallel to AB. So I draw a line parallel to any of the sides. And once again, I will notice very similar results to what I have just worked out, that this line EF will divide the sides in the same ratio. That means AE upon ED, AE upon ED is going to be equal to BF upon FC, is equal to BF upon FC. So once again, somebody can share this as a result, but my question again would be, how do I prove this? Because proving this itself is a challenge or a problem for us, right? So let's get started. What I will do is, I'll connect A with C so that I can get triangles into play. Now I can see very quickly AE upon ED, let me call this point G. AE upon ED is going to be equal to AG upon GC. Why? I'm thinking of triangle ADC, this triangle only, forget the rest of the story. EG is a line parallel to one of the sides, that means it will divide the other sides in the same ratio. So whatever is the ratio of AE upon ED is going to be the ratio of AG upon GC. AG upon GC. And now take the same step forward and think of triangle ABC. Triangle ABC is going to be like this. And once again, GF is a line parallel to one side of the triangle. Only your orientation has changed. The idea is still going to be the same. The ratio of AG is to GC is going to be the same as the ratio of BF is to FC. That means because of this triangle ABC and this being a line parallel to AB, I can say AG upon GC is the same as BF upon FC. So AG upon GC is equal to BF upon FC. And therefore proved, because you said AE upon ED is equal to AG upon GC and AG upon GC is equal to BF upon FC. That means this is equal to BF upon FC, and you can directly jump here. So even when you see a trapezium and you see a line drawn parallel to one of the sides, you know that line is going to divide the other two sides, the non-parallel sides, in the same ratio. So let's try one more problem and try and apply the theory that we have learned. This is the information given to me that PQR is a triangle. PS upon SQ is equal to PT upon TR. This is one part of the information. And the other is angle PST is equal to angle PRQ. This is the other piece of information given to me. And one more piece of data is that PQ is equal to 6. So PQ is equal to 6 units. And your question is, what is the value of PR? So let's get started. It was not given to me that ST is parallel to QR, but the moment I look at this piece of information that the ratio of these two paths is the same as ratio of these two paths, I know ST is going to be parallel to QR. So ST parallel to QR is also something I know. The moment I have this, I notice ST and QR are parallel lines and PQ is a transversal, and this angle are corresponding to each other. That means whatever is the value of angle PST, the same value is going to apply for angle PQR. And I already know angle PST is equal to angle PRQ. This angle is equal to this angle is equal to this angle. That means these two angles are equal to each other. Now using the theory of isosceles triangles, if two angles are equal to each other, the opposite sides are also equal to each other. Now it's done. PQ is 6 units, so PR is also going to be 6 units.